That's perfect.
Okay, good. So thank you very much, Emmanuel, for the introduction, and even more for the invitation to be here. It's a really interesting session, and I'm really looking forward to the discussion. So I hope I don't disappoint you, because I'm going to be showing things that are completely different from what I showed last year in Lisbon, and they don't have a lot of networks. They have a little bit more of an exercise of trying to understand why is it that people share fake news? Why does someone look at some sort of information online or whatever it is and decide to share it, knowing or not knowing that the information is fake? And the work that I'll be presenting is being developed by my team. This is the pre-COVID photo, and this is the post-COVID group. And we are, so everyone is working from home still. And I'll be mostly presenting the work today of Frederico Francisco, who's a postdoc in the lab, and who is left to join the government, and Simona Lackner, neuroscientist, and the current postdoc in the lab as well. So the type of work that we do in the group in general has three main lines, but I think I'm going to try to convince you that they're all very connected. So we work a lot on health, and now there's a good part of the group who's working on the pandemic, of course, on COVID, and so we do a lot of emergency nowcasting and trying to use different data sources to identify diseases in real time. And we do a lot of political discourse and political networks, and this is why we do the type of work that Emmanuel was describing, that we've been working on also for some years now. And we do most increasingly behavior. So the idea is that we can use networks, we can use data science, we can use the type of digital breadcrumbs that are being left everywhere at every minute by everyone to understand cognitive biases and to understand human behavior. And this is the only part that I'll be talking about today, is whether or not we can use data science or complex systems to understand biases in decision-making and attitudes towards science. And the context, of course, is the context of the post-truth that people have been discussing a lot, and this idea that it's very difficult to distinguish what is true and what is not, and even that the truth has not been valued. The idea that we should be telling the truth is not been valued. And I'll start with three paradoxes. So the first paradox is that life expectancy has been increasing, and arguably science has been making people's lives better for quite some time, but the trust or the confidence that the people have in scientists and medical doctors has been, and these are these blue lines over here, has been remaining the same, or if anything, even dropping with time. So the second paradox is that offering information does not improve trust in scientists, or does not improve how much people love or believe in science. So for a really long time, the idea behind science communication in general is that to know it is to love it. So the more you know about science, the more you'll like it. So what you'll have to do is to offer information to the general population and expect that this will translate into a bigger support towards scientific activities. But not recent, in the beginning more or less in the 90s, people started to realize that this is not true, that there is no linear relationship between how much you know and how much you support science. Sometimes there's absolutely no correlation, and sometimes you have an inverse correlation even. And then the third paradox is that it might even make it worse. So the more we discuss some subjects, and we don't know what is causing what is, we don't know what is causing what. We know there's a correlation between these, and we know that the more we discuss some subjects, the more polarized people become, or the even less they believe in scientists. So in this case, the percentage of US adults who say that scientists, for instance, understand the health effects of eating genetically modified food is less than 20% of US Americans think that scientists understand this very well. And this is true for other controversial issues. And in fact, this is from a 2017 paper. This polarization increases, and there is indeed almost no relationship between what you believe and what you know. So for these two examples, climate change and human evolution, what you see here is that this is science literacy here in the x-axis, and in the y-axis is how much you believe climate change is real or that human evolution actually happened. And here you have the science literacy, and the different lines correspond to different political orientations or identities in the United States. And the expectation would be that the more you know, the more literate you are, the more you think that climate change is true, because that is aligned with the scientific consensus. But what you see is that it's completely dependent on your political beliefs. So it's true if you are extremely liberal, which is the black or the red lines, but it's completely not true if you are conservative, or even slightly conservative. So the question of why is it that people will believe the fake news? Why is it that people believe that the earth is flat, in these cases in the scientific context, and why do people share them? Okay. And there is, of course, for me, this was one of the papers that came out in March 2018 that really played a big role in shedding some light into this. It made the cover of Science. This is from a group of Sinan Aral at MIT, and what they saw, that they looked at many different tweets over a large period of time, mostly up to the US presidential election of 2016. And what they found was that the falsehood diffused farther, faster, deeper, and more boldly than the truth when they compared fake news with real news. But the thing that really struck me as being very interesting is that up until this point, there was this general belief that robots or the bot accounts were the main responsible for this sharing. So they were planted, it was deliberate, and they were just like amplifying the reach of fake news very much. But what they saw was that indeed the robots accelerated the spread of true and false news, but they did it at the same rate as of true news. So they spread both true and false as if they couldn't distinguish. They would just like retweet or reshare. But the ones who had the preference for the fake news were the humans. So the humans are the ones who are more likely to spread it. And more likely is actually a lot more likely. So red is always false and green is always true. And what they saw was that indeed fake news gained or beat true news on all possible standards. They reach the higher number of users faster, they stay in the network for longer, they reach a lot more people, they cascaded more, so they were more repeated. And this is another very interesting part. So what they did was that they looked at the titles of the news and tried to and did a little bit of sentiment analysis to see the type of emotions that they elicited. And the more surprising and the more disgusting they were, the bigger the gap. The more they would be shared, like the more they would have, they would be interacted with, and the bigger the gap between the true and the false information here. And at the first pass, it seems like, okay, we know this. We know if they're very shocking, people would share them more. But then if we think about it for a second, it doesn't make much sense, because why would you share something that is so shocking? You should have some sort of a switch in your brain saying, this is too weird to be true, or this is so strange, I don't know that I can believe it. So you should be less likely to share them because you should doubt them more. But in fact, even now during the COVID pandemic, there's a lot of false information being spread and around. And there are some that really go along these lines of like, it seems like our switch of being a little bit more careful or doubting ourselves is off. So in this case, I don't know if you remember this, but in the beginning, right in the beginning of the coronavirus pandemic, most people had never heard of coronaviruses before. Like you say, you have a cold, but you don't know if it's a rhinovirus, if it's a coronavirus, what type of virus you have. And so then people went and they found out that bleach was probably, it's a very strong disinfectant, so that you could use bleach to disinfect the surfaces. And when people picked up their bleach, they saw that it says, oh, it kills 99% of all microbes and bacteria and viruses, including coronavirus. Okay? So coronavirus is a very large family of viruses. They've been around for thousands of years. They've coexisted with humans. But for the majority of people who had never heard of coronaviruses, this came as a shock. So the idea is like, how is it that the bleach that has been sitting on my pantry for months now knew about coronavirus? Okay, so this was widely shared as proof of a conspiracy theory. So the government knew in advance about the coronavirus. So because what other possible explanation could there be for the fact that I had that it says human coronavirus on the back of my bleach? And a simple Wikipedia search would solve this problem. But the step of I don't understand what's going on was not made. And then this is another example from this person. And this person is a vlogger and a student with huge amounts of followers on Twitter. And this was one of the first websites that was taken down out of Twitter, Zero Hedge. And they had shared political content that was suspicious for quite some time, but because they shared false information regarding coronavirus, they were taken down. And Pardy says, so Zero Hedge was banned from Twitter after covering a study finding HIV inserts in 2009 coronavirus sequence. This article suggests that the virus might have been created as a bioweapon. So this was a paper that was on archive for less than a week because it was taken down because it was not good. The bioinformatics, the way the alignment had been done was not good. The probabilities that were calculated were not properly done. But there is strong reason to believe that parties did not know anything about DNA alignments, blast, sequence recognition, probabilities of identifying similar sequences, none of that. But still, she would share an article, a tweet to her thousands of followers, again, supporting a conspiracy theory. So it's as if there is, again, this switch of like, I don't know enough about this, so I shouldn't talk about it, is just not there. And this kind of leads us to this illusion of the rational agent that economists are famous for, and the idea that we are very rational, so we maximize everything that we do, and that we should have a completely rational behavior. And of course, this is not the case, and I'll be using these two characters to illustrate. Okay, so this is, I'm going to use a lot of the talk is really going to be on how can we learn about fake news, or how can we learn about behavior from fake news? And so there's going to be a lot of thinking about human behavior. So again, let's go back to the very linear, simple relationship that you would expect that how much you know and how much you think you know should be linear, and there should be some sort of a very simple relationship. The more I know, the more confident I am. Okay? And this would be the ideal case. But of course, we know this is not the case. We know that confidence grows faster than knowledge. And this means that how much I know grows linearly like this, maybe, or if it grows linearly like this, how much I think I know grows much faster. So I tend to overestimate how much I know. And there's this gap. Okay? So the gap of overconfidence. And we've been thinking about the spreading of fake news as a deviation from pure rationality, or from a bias in decision making, as the psychologists typically call it, cognitive psychologists. And the idea is that if you are more confident than knowledgeable, so if you actually think you understand what's going on in terms of viral sequence and the back of the packaging of bleach, you are clearly overconfident. You're way over your head, and you are more likely to share fake news. And this is a hypothesis. And the reason why we're trying to do this exercise is because for most of the work that we typically do in big data, and there is no theory behind it. We have a lot of data, we extract a lot of data, and then we just see what comes out of it. And what we're really trying to do is that we're using theory from cognitive psychology, so that we can devise hypotheses, very simple hypotheses that we can test. And this is one of them. Okay, so do people who have a very big gap, overconfidence gap, share more fake news than the others? And this idea that confidence grows faster than knowledge has been known for quite some time, more than 10 to 20 years ago, and it's known as the Dunning-Kruger Effect. The idea that your perception of your knowledge and your knowledge are not completely aligned, and so if this is your actual test score, your perceived ability is typically higher, except when you're an expert, when these two cross. And this comes together with another thing that people have been studying for a really long time in psychology, called the confirmatory tendencies. The idea that we tend to find information or search for information that confirms our biases, what we already believe, and that if we find information that does not confirm them, we just kind of disregard it. And this is probably being made worse by Google or the digital era, just because it's so easy to find information that confirms what is it that we want to think, but it's been known for a really long time. And Francis Bacon, the 17th century, said that human understanding, when it has once adopted an opinion, it draws all things else to support and agree with it. And there can be a lot of examples, instances on the other side that we either neglect or despise, so that by this cycle, the authority of my former conclusion remains inviolate. So we just do this a lot. And of course, there's always a Trump tweet and a New Yorker cartoon for every situation. And in this case, it's Donald Trump talking about vaccination and saying healthy young child goes to a doctor, gets pumped with massive shot of vaccines, doesn't feel good, and changes autism. Okay? Many such cases. And then, of course, confirmation bias, and people say, yes, thank you. Okay, thank you for hearing us. This is exactly what happened to my kid. And then, and this is a fun one, but with a lot of consequences, like this one is very consequential. So but the joke is that these Mac pilots have lost touch with the regular passengers like us. We can do it as well as them, so who thinks I should fly the plane? And the thing is that the way we've been trying to tackle fake news has really been on the technical side. So this is from the European Union Act on Disinformation, and they talk a lot about being multidisciplinary, which of course is very important, but it's mostly technology driven. Like, we have to regulate the platforms, we have to be better at identifying bots, we have to give information, which is something that we know doesn't necessarily work, and they completely ignore these biases in human behavior, which are the biggest drivers behind the actual sharing. So in summary, for this first part of the introduction, humans have a preference for sharing fake news. It's not that just they share fake news and true news at the same rate, there's a preference for sharing them. Then we cannot fully tackle this problem unless we understand the human side, but the problem itself will allow us to learn about humans. It can be a tool, a model system to understand the human side. Okay? And then the social networks are amplifying this problem because they're making it faster, and because they reach a lot more people. But the social networks, exactly because it's kind of like a magnifying glass, make the problem very visible and easier to study. So we argue that fake news are an elegant resource for social sciences to understand human behavior. And the way we do this, or the way we're tackling this, is by creating a framework in which fake news are like a disease. They are like a virus. And we even say that fake news have gone viral. So we treat fake news as any other type of pathogen that will spread on a network. And this is going to be the environment in which they are spreading. And then the humans are the hosts, and are the ones that are doing the sharing and get infected, and it can infect others. Okay? And then we can bring a theoretical framework from epidemiology, from complex systems, from networks, from how we know information spreads online, and put this all together. And today I'm only going to be talking about this little part of how we are looking at different susceptibility of humans. Okay, so I'll go through this a bit faster, but the idea is to create a series of data sets. So we start with the pathogens, and we collect fake and good news, and this work is mostly done not by many different people. And then we'll look at the environment by looking at social networks, the connections, the profiles, and the sharing history. And then we really need to think about what does it mean to have individual susceptibility or heterogeneity at the susceptibility level. This is where I think there's a lot to learn, and that we can bring it together with these dynamic models. Okay? So one thing that so how do we measure confidence? How do we know that people are self-confident or overconfident? Most of the measures, including the Dunning-Kruger, they are self-reported. So I ask you, how much do you know about this subject? And in fact, people tend to overclaim how much they know in different groups and in different ways. But what we're proposing here is an indirect measure of confidence. And this is the idea. We can, in principle, apply it to any survey that has true and false questions. So you can, for any question, like, is an atom bigger than the electron, or is the electron bigger than the atom, you can think if it's true or false, or you can answer, I don't know. Again, if we have our 100% rational person, what you would see is that the number of correct answers will be linearly correlated with the number of don't knows, because if you know, you get it right. If you don't know, you say, I don't know. And only getting it wrong or giving the wrong answer is a deviation from this perfect line, meaning that you say, you think you know, but you answer wrongly. Okay, so then you're going to have a curve that has this gap between what would be the ideal theoretical rational attitude and the common attitude, which is you think you know, but you actually don't. Okay? So Federico and Simona went back to look at one of the largest surveys that we've ever had. So these are the Eurobarometers that European Union keeps on doing. And this particular one was on science and technology. It ran for many years in many countries for a total of around 85,000 independent surveys. And they asked about knowledge. So they have these knowledge questions. Does the earth revolve around the sun, true or false? And they also ask about attitudes towards science. And what they saw was that this would be the expectation, the linear expectation, but in fact what they saw was it would have a deviation, exactly like we predicted. So, and what is interesting here is that people answer wrongly, not so much when, so this is zero knowledge, so zero knowledge and all of the answers correct. And this would be, there should be, if you know everything, you have 100% knowledge. If you don't know anything, you should have 100% don't knows. And then what we see is that we have this curve over here. And the place where people answer wrongly the most is not for low knowledge levels. It's for intermediate knowledge levels. So there is this gap, this where you know something, you don't know a lot, but you know something. You overestimate how much you know. And because of that, you give the wrong answer. And this is the interpretation that we're doing. This is the same thing, but for incorrect answers. And then Simone and Federico looked at this for many, many different countries. And so again, here is knowledge, and here is how often you say, I don't know, okay, the y-axis. And let's say, let me pick, for instance, Portugal. I could have picked Italy. It's very similar. So in Portugal, when you are at zero knowledge, 80% of the times you answer, I don't know. Okay, you get them all wrong, or you get them all of the 80%, of the 100% of questions, 20% you get them wrong, and 80% you say, I don't know, when you get them, none of them correctly. But for instance, if you look at Norway, in Norway, for all of the questions not being correct, 60% you get them wrong, and only 40% you say, I don't know. So Simone and Federico did this for all of the different countries, and they were trying to compare. And what we see is that actually if you order them by latitude, which there is a very strong relationship by attitude, and with the Nordic countries like Sweden, Finland, Norway, being more likely to get them wrong for the same level of knowledge. We're not having different knowledge levels to get their answers wrong, whereas Cyprus, Portugal, Turkey, Italy is here very close. It's much more likely for the respondents to say, I don't know, when they don't know the answer. And there is a gender difference. So the green line is for females and the purple line is for males. So males are much more likely to get the wrong answer than to say, I don't know. So in these cases, the probability of never responding don't know when it's higher for males. So, and just so that you see some network data, and it's not just behavioral data, this is a very recent paper came out in Science Advances where they were looking at how this information is polarizing and how this information is different for the US Congress. So this is in the case of the Congress members in the United States, and they saw that on their tweets, what they were sharing online regarding this COVID disease, they saw that there were terms that were much more used for Democrats and terms that were much more used for Republicans. But what is interesting here is that when they trained a random forest to identify if the tweets were from Democrats or if the tweets were from Republicans, in the beginning it was very poorly. The classification was not working so well, but then it kind of converged very fast. And from January, in January, you couldn't really identify, and in March, the distinction became very clear. So they got it right 75% of the times in the classification of the Congress members. And the interpretation here is that they polarized very fast. So this is the interesting point. The interesting part, especially for in this case of COVID, is people have no opinion and no expectations about this a couple of months ago. And now people all believe that we should wear masks, or all believe that we should not. And there is a very strong level of confidence in one's position. Okay, so this is to finish. We do see that there is reason for a large heterogeneity in the population in terms of confidence and in terms of behavior. We know it varies, this confidence varies with age, with gender, with social characteristics or cultural characteristics with beliefs, and also people are in different environments, or they see different subjects and they're in different contexts. So we can bring all of this together that I was describing before and really test hypotheses. So we can test the hypothesis not only that the overconfident and the unknowledgeable are more likely to share fake news, but also, for instance, that less diverse social networks, people on these networks will be more likely to share fake news. And the important part here is that we really need to create tools to make this very ethical, to make this very anonymous, distributed, and encrypted, so that even if I identify people that are very susceptible to fake news, and even if I learn from the psychology perspective that this is true, or that there are some characteristics that make people good target, we have to decide what we're going to do with the results. Because in fact, we've created this macroscope that allows us to look at humans in social networks, but we're also creating a tool for surveillance and for understanding things regarding that make people very good targets. So we do think that the big data can help understand human behavior, and we can use it as a tool to study fundamental science. I'm not talking about applied anything, but we need to turn this into an ethical macroscope with very ethical concerns. Okay, so we need to think about controls on data. I was a big proponent of open data, and I'm no longer one. We have to improve privacy protection, and we have to decide what we do. Should we publish? If we identify people that are susceptible to fake news, should we publish these results? And I'll finish with this. This is from Warren Weaver, which is considered one of the founders of complex systems, and he's talking about these complex problems, things that bring together cancer, behavior, all of these different things. And there's the idea that there's a promise on the horizon that is new, that these advances can be accomplished, like learning about what he calls organized complexity. And there are two instances that it finds especially promising. This is in 47, right after the World War II. And the first piece of evidence is the wartime development of new types of computing devices. Okay, so here he's talking about these big machines. And then the second is the mixed team approach, and what we would now call a multidisciplinary team of people working together to tackle these problems. And I would add that it's true, now we have this, we are really going this, and now we have to think about these problems ethically. So this is what I had to share. Thank you.
So thank you very much, Joana. And now this is time for, we have time for question from attendees. We have already a question in the question answer chat. I will read it for you. Can you explain how you determine what is and is not fake news?
Yes, so we're completely dodging that problem. So why? Because in this case, what I'm considering is all information that is arguably false, whether it was planted or not. So it can be even a satirical piece, a joke that people interpreted as being true, and then this was it's believed to be true by other people, and it's shared. What we'll do is that we will not classify, or what we do is that we don't classify true or fake news. We rely on fact-checking sites to do the classification for us, and then we get to select the ones that are absolutely false, like there's no basis to that claim, to do, and ignore the ones who could be a little bit more dubious, because there are some that can, for instance, have a basis of truth, but then be in a different context, or the image, or using like a photo that is from a different place. So there are different gradations of falseness, but because we are not particularly interested in fake news, we are using fake news as a model system to understand cognitive bias and behavior. We can overcome those issues by really selecting the ones that are obviously false. And we typically think about fake news as being political, but many of them are pure clickbait. They're just for ad revenue. So there are a lot of things like animals that escape the zoo and rape people along the way. Okay? Like there's no ideology here. It's just people just want to cash in on the gullibility of others. And for our case, it doesn't really matter.
Thank you. I don't know if Milan, I don't remember who is the author of the question, but if he or she want to comment, he has the chat here. And if other attendees want to make a comment or a question, can type it on the chat or raise your hand. Meanwhile, I have a couple of questions too. The first one is about this kind of effect you observe that are related to geographic context and cultural context. So uh, when you give an explanation based on cultural and geographic context, is always controversial, but you found a quite significant correlation in those European surveys. So do you think that you need to put culture and geographic context inside your model in order to understand what is going on? Is something necessary?
What is interesting here is whether or not we have heterogeneity in susceptibilities to fake news. When this heterogeneity can be of many different types. But if one hypothesis that can come out of it, so is that if these ones are the ones that have the biggest gap, right, there are some countries that will be more likely, there are some groups of people that are going to be more susceptible to fake news than others. Of course, this can be counteracted by many different factors. It's never going to be this linear, but it will give us, again, hypothesis that we can test. And for us, this is really important, that we're not having a blind approach of whatever we get, because with big data, you always get something, always. No matter what, you get something, and it's significant, statistically significant. Whether or not this means anything or increases our knowledge, that's a different question. And from our perspective, it more often than not might not. So the idea of really having hypotheses that you can test, it's important. But it's true, not only it's true that all of these things are typically very controversial, we see a trend line in the opposite direction that people typically think, which is the direction that the ones who really say, I don't know a lot more, are less educated, and maybe people would guess that they would be more susceptible to fake news. But for us, the interesting thing is that it's not only the knowledge is important, but it's not only the knowledge that matters. What matters is this ratio.
Thank you. And okay, I ask to attendees if they have comments. If not, I have one other very last question. I wonder what is, in your opinion, the path between scientific knowledge about the phenomenon of fake news and to manage the problem? If it is through public policy or to school, or what is, in your opinion, in your experience, the relation between what we know about how fake news diffuse and what we can do to reduce this exposition to fake news?
The way we're approaching this is it has everything to do with trust. It has very little to do with knowledge, or some to do with knowledge, but much more to do with trust. So what does this mean? It means that if you can increase trust in scientists, health authorities, and so on, you will reduce the likelihood of this particular fake news being shared. If you increase trust on a certain newspaper or outlet or so, people trust these ones as the fact checking. Everything else, I don't think it's going to work. So, for instance, in the case of fake news, in the case of Facebook or Twitter, taking them down only reinforces conspiracy theories.
Yeah.
The moment they are down, people just say, oh no, look, we were getting closer to the truth, so now they are hiding it even more, right? So just the effect of deleting accounts is different. But deleting the fake news in itself can possibly just amplify even more the polarization. And that's why I was showing that information for the Congress people. The polarization is so fast that in a couple of months, people took sides. And they took sides on an issue that the majority of the population knows absolutely nothing about. So this has nothing to do with being informed. This has nothing to do with being able to make an informed decision and a rational decision, and everything to do with taking sides. And you are going to take sides along your lines. So if you develop, and this has to be done over a really long time, a culture of trust in some authorities, you will, this is hypothesis, become more protected against this information from the other side. But it's much more emotional than rational.
Thank you. And the last question in the question answer chat is from Marta, that asks, could you please deepen on the explanation about the feature of news that people are more likely to share? You say shocking or disgusting, and then Marta asked also for some reference if you have on that subject.
So this is a reference from Sinan Aral's paper and the group. And I'm sorry, I have a really hard time saying Bozogi's name. Is the first one. That's the only reason we keep mentioning her. Okay, and this is the figure that I was mentioning from that paper, where they compare the titles of the titles of the fake news and the true news, and the biggest gap between the green and the red is if they are surprising and disgusting. And the more surprising, the more disgusting they are. So like we can in general think about this as shock. They are much more likely to be engaged with, shared, liked, with all of that.
Okay, thank you. So
sorry, I have a question. I'm sorry, maybe I don't know where to ask because I'm on the panel. Maybe I can't type an actual question, but so I'm just going to take this chance to ask now. Thank you so much, Joanna. It was a really interesting presentation. So one thing that I picked up, I thought it was interesting, and maybe we can discuss a little bit more, is that this overconfidence measure seems to be quite an important behavioral measure of what you're studying right now, right? And the way you're trying to capture that is by saying basically whether you have the knowledge. There's a mismatch between knowledge and admitting if you have knowledge or not, right? And I wonder if there's an additional component to this in addition to overconfidence. And what I'm talking about is the potential for social desirability bias, right? And I think this is something that might be a strong predictor of whether people admit to basically whether they know something or not. And I was wondering if you had some thoughts about how maybe we could tease out the difference between being overconfident or being scared of admitting that you don't know something.
Yes, so thank you for that. So the measures in psychology, like there are many different types, and we're proposing new things. So we still don't know how well they're going to be taken by the psychologist crowd. But in this case, because of those concerns of social desirability, we are creating an indirect measure of confidence, right? So people think that they're being tested for their knowledge, whether they know or not, but actually what we're measuring is something else. And Simona has been running some surveys, and I'm not showing any of this data, but she's been running a lot of surveys in which, for instance, she forces people to answer, and then she asks how confident you are in your answer, or if you had to guess which one would you, so that you can really separate from like knowing and not knowing. And we also ran some experiments. These ones are with students, so they always have limited generability, in which they have to pay. So there's a cost for getting it wrong. So you get money if you get it right. You don't get any money if you say I don't know, and you lose money if you get it wrong. So we're using like a series of behavioral experiments and different ways of asking the questions. We're really trying to get to this. But as much as possible, we're trying to come up with ways to measure this that are completely indirect. So we do all of the social network work on understanding the connections and the networks. And I think Walter is going to be talking about some work that seems very similar to what we are doing or plan to do in different ways. But here what we're really trying to see is, can we get very specific metrics of subtle differences that can help us understand what makes people susceptible and the types of heterogeneity that we have.
Thank you. I think that's, yeah, I think of the many things that you talked about, I think the reward for getting it right, or sorry, cost for getting it wrong, that one is a really convincing measure if you could apply this to all of your studies.
Yeah, there's also a problem here with the risk aversion. Okay, so if the cost is low, people tend not to be risk averse, so they will tend even to risk more. So I don't know how much money we can spend on making sure that people don't want to risk it.
Yeah,
so there are other biases here that are taking place. It's a completely new field for me. Like none of us in the group is psychologists. We're hiring psychologists now, but we're all like physicists or computer scientists. So it's been very challenging. But I really think this is the way to go.